Hello, my name is Jim McVeigh, and I'm a prototyping solutions architect at AWS. This video is part of a series of videos about the OPA on AWS open source solution to provide AWS-related functionality in your Backstage developer platform. In this video, we're going to dig into customization of software templates in OPA to describe unique scaffolder actions and how you can build and contribute your own templates to customize the solution. We're going to take a closer look at building software templates to create new environment providers or new AWS applications. The end goal is to provide these new templates to end users to easily build out new environments and applications in AWS. There's extensive documentation available in the Backstage URL shown here. If you're not familiar with Backstage's software templates, I encourage you to check out the docs. We won't cover the generic details of creating, deploying, and testing templates, but we will focus on specifics that are unique to OPA-related templates. When creating a new template, there is generally two key sections where you'll spend the majority of your time in your template YAML file. The first is the parameters section. This is where you'll provide information about the input variables that your template will require. You define the input field types and display options to render them to the end user in the Backstage UI. The OPA on AWS solution doesn't provide any custom input parameters, so you'll generally be using the capabilities provided by the Backstage platform. Let's take a look at the actions that will be taken after the user provides the requested input. This is going to occur in the steps section. This is the other key area of your template YAML file. In the steps section of the template, you define an array of the actions that you want to execute when scaffolding your software. For each step sequence, you define an ID, name, action identifier, and optional inputs for the action. Let's take a look at action identifiers provided by OPA on AWS that you can use when building your own templates. There are 5 key custom actions to cover, and they are all prefixed with OPA:. We'll go through these individually to describe their purpose and then describe a general pattern that you might use these actions in when building your own templates. Within your Backstage application, you can navigate to the /create/actions path or select installed actions from the action menu in the Create a New Component view to view a list of all available actions with their documented input and output parameters. Let's start with the Get Platform metadata. This action retrieves information about the platform where the Backstage and OPA on AWS solution are running. At this time, the key piece of metadata returned is the AWS region for the platform. This may be useful for subsequent infrastructure as code invocations or GitLab pipeline executions. The Get Platform Parameters action is designed to retrieve AWS SSM parameter store values from the platform account. The OPA on AWS solution parameters are prefixed with a /OPA path. This action is useful when you need to know about information stored as parameters, such as the pipeline role and the platform role. Another key action is the Get ENV Providers action. When a developer creates a new application, they'll need to specify the AWS environment where they want the application to be deployed. This environment is usually prompted as an input parameter on the UI and can be fed into this action as input. This action will then look up all of the environment providers associated with the defined environment and returns an object structure, such as the one shown here. This action provides critical information that you would supply into a CI/CD GitLab pipeline and the Terraform or CDK infrastructure as code executed in that pipeline. The Create Secret action simply allows you to create a new Secrets Manager secret in the platform account. It does not create a value for the secret. It simply creates the AWS resource and returns the ARN for the newly created secret. The next action is often the recipient of the output from the Create Secret action. The Create Repo Access Token GitLab action will connect to a GitLab instance, create a personal access token for a specified repository, and then store that token in a Secrets Manager secret ARN that you pass as input. With this repo access token, authorized developers will be able to clone the repository to begin their coding. Now that we've provided an overview of the custom actions provided by the OPA on AWS solution, let's take a look at a common pattern that you might use for software templates. Keep in mind that this is just a general pattern. When creating your own templates, you have the flexibility to build out your template steps as you see fit to meet your company's processes and patterns. You would first get basic information from the platform. That's going to include metadata about the platform and any SSM parameter values that you'll need in subsequent steps. Software templates usually have skeleton code that is fetched from a remote repository. The fetch template action from Backstage will pull down the skeleton code into a temporary working directory and then proceeds to perform placeholder substitution in the skeleton code with input values that you pass into it. The first of two fetch template actions that we'll perform is to fetch the environment provider base code, which includes files such as the Backstage catalog info YAML file, base GitLab CI/CD YAML files, and a properties file for environment variables used by the pipeline. In order to foster reusable code, you may have some common infrastructure as code in a separate repository. Therefore, a second fetch template will pull code from another repository location where IAC, Terraform, or CDK code resides. Just like the previous step, the fetched code will be added to the current temporary working directory, and placeholder substitution occurs with the input values that you provide to the action. Once all of the required code has been laid down in the temp working directory and updated, then the source code is pushed to a GitLab repository with the publish GitLab action. As part of the base template code that we fetched, there was a GitLab CI/CD pipeline file, so a new pipeline job will be immediately kicked off to build our code for the new environment provider. Finally, we want to register the new environment provider entity in the Backstage catalog, so we use the catalog register action to add it. If you'd like to review more specifics and a working example of these steps, see the AWS ECS environment provider sample in the Backstage reference folder of the OPA on AWS open source repo. Next, we'll do a quick overview of a common pattern for building AWS applications. Similar to the environment provider that we just examined, we start with getting platform information. Next, we will have prompted the user for the environment that they want to deploy to, so we'll gather information about that environment and the associated environment providers using the get-env-providers action. We create a secret that we'll use later to store a repository access token secret, and then we'll fetch the skeleton code for the application and perform placeholder substitution using output from the previous action steps. The base code for an application is usually your Node.js, Python, TypeScript, .NET, or other language source code, along with a CI/CD pipeline definition file. Just like we had with environment provider templates, we may have reusable infrastructure as code that we'll fetch and add to the temp working directory. And then we'll push that source code to a GitLab repo, which will immediately trigger a pipeline to build out the code and push it to AWS. So that we'll have a way to offer authorized developers a simple way to clone the repository, we'll create an access token and store it in a secret, and then register the new application into the Backstage catalog. There are several application template samples in the Backstage reference folder of the open source repo. Once you've built new software templates and supporting files, you'll want to test it and make it available to end users. The first step is to put the template code into a GitLab repo. Then, in your Backstage application, you'll register your template by pointing to the template YAML file in your GitLab repo. Registration can either be done via configuration of the Backstage app config YAML file or through registration of the new template in the Backstage UI. Refer to the Backstage docs for details. Once the template is registered in Backstage, you'll see the template in the UI, and you can proceed with testing and making it available to end users. That concludes the overview of templates using OPA on AWS to simplify the creation of standardized environments and applications in the AWS cloud. Make sure to watch other videos in this series to learn more about OPA and how it can help you scale your development.